So let's look at the deployment. A Kubernetes deployment or the deployment resource is a wrapper around the replica set. And this wrapper allows you to do controlled updates to your pod. For example, if we wanted to update the image name that all of our pods use, we can update the pod template in the deployment, and then the deployment controller will go and recreate these pods with the new image. So let's use the exact same example as before. So instead of replica set, I will create a new file called deployment.yaml, and I'll paste into the deployment.yaml. It looks exactly the same as the replica set, right? The only difference is the kind of the resource. The resource is named deployment as well. There's also the replicas, the number of replicas here. There are the selector labels as well. And there's a template for the pod. This is a template that describes our pods. So let's create this deployment. kubectl apply -f deployment.yaml. And I will also add a -- record flag. So this flag, what this is doing, it's telling Kubernetes to store the command we've executed in an annotation called change cause. So this annotation is useful, or this way of creating deployments or resources is useful if you want to track the changes or if you want to track the commands that were executed when the deployment was updated. So we'll see this, how this -- record flag works in an action later when we do rollouts. So let's create the deployment. And to list all the deployments, we can use kubectl get deployment. And this will show us a single deployment. You'll notice that the pods are still spinning up, so only 2 of them were ready. So let me clear and let's try again. Okay, so now we have 5 of 5 are ready, 5 are up to date, and 5 are available. So the output looks exactly the same as before when we listed the replica sets. So let's look at how the replica set looks like. Now notice that in this case, the replica set has this random portion in the name, just like the pods did before. And if we go one level deeper and we list the pods, you'll notice that the pod names are getting longer as well. So you'll notice that the deployment is called hello, and then this deployment creates a replica set and adds this random string at the end of the name. And then the replica set in turn creates all the pods. So the pods are named as the replica set plus this semi-random portion at the end. So let's see what happens if we try to delete one of the pods. So I'll just delete this first one. Let's list them. So the pod will get terminated, but you already see that this was the new pod that was brought up while this other one was being terminated. So let's see how we can scale the pods, increase the number of replicas, scale the pods up, or decrease the number of replicas, scale the pods down. So Kubernetes CLI has a command called scale, and using this command, we can scale the number of pods up or down. So let's go from, so we have 5 of them running right now. Yes, so there's 5 of them. So we can say kubectl scale deployment. So we're scaling the deployment, which in turn is going to change the number of replicas, and that's going to trigger the replica set controller to delete the pods or create new pods. So we're going to scale the deployment. Our deployment is called hello, and we'll say we want 3 replicas. So the deployment was scaled, and then if we look at the number of pods, you'll see that 2 of them are being terminated, and there will only be 3 of them left. So if I list them again, it's still being terminated. By the way, you can use the flag -w, which stands for --. And this will just keep the it's not going to exit the command. It's going to watch the changes that are happening to the pods in our case. Let's see if it's actually being deleted now. All right, it's taking a while, but you'll see that there's only 3 of them running now. And then similarly, to scale up, we can say kubectl scale. I'm just going to use the short name deploy, and we'll say replicas equals 5. And of course, we have to provide our deployment. And the hello was scaled. Pods. And you'll see that one of the containers is still being created. There's already 4 running. And now there's 5 of them running again. Now remember when we were using a replica set, you noticed that the pods were not automatically restarted when we updated the image name. So this is something that the deployment resource can help us with. So let's use the command called setImage to update the image in the pod template. So this is down here in the template of the deployment. So we're going to update the image name BusyBox to BusyBox 1.31.1. So let's do this. So we're going to say kubectl set image on the deployment called hello. And we're saying in the hello container, remember that you might have multiple containers running. So you have to be specific as to which container you're updating. And then we'll say BusyBox 1.31.1. And then -- record. So I'm not going to press enter. What I'll do is I'll create a separate terminal window down here, and I will run kubectl get pods -w just to watch what's going to happen to the pods. All right, so we're ready. We're watching. So let's press enter here. So there you go. There's a lot of stuff happening here. The pods are being terminated. The old pods are being terminated, and the new pods are being created. So this is what the replica set could not do for us before. So what deployment did is it scaled down the pods that were controlled by the previous replica set, and it actually created a new replica set. So you'll see this is the old replica set that was created originally when we created the deployment. But now when we were scaling, when we updated the image name, deployment created a completely new replica. And this new replica set is running or created all the pods that are using this new image. So let me just exit from this one, and we'll say kubectl get pods here. So we, again, have 5 pods running. And let's just do kubectl describe pod. And just so we can double check the image name, I think it should be here. There. So this is the image name that we've updated. And it's the BusyBox 1.31.1. Now remember that -- record flag that we're setting? What we can do now is we can use the command called rollout history. And this command will show us the results of the previous rollouts. So one of the previous rollouts that we did is when we changed the image name to 1.31.1. So let's do kubectl rollout history for the deployment called hello. And you'll notice there's 2 commands or 2 revisions. So the first revision was the original command when we created the deployment. And then the second one was when we actually updated the image name to BusyBox 1.31.1. So this command will show you all revisions that were made to the deployment. Now let's say that we rolled out our deployment to this new image version, but for some reason we want to go back to the previous state. Using the same rollout command, we can also go back to the previous revision or just do an undo. So undo a rollout. So let's do, just going to clear the screen, and we'll do kubectl rollout. So we're going to undo the rollout to the deployment called hello. This one. So the response is saying that the deployment.apps/hello was rolled back. So what we did here is we rolled the changes back to the previous version. So let's look at the pods. So you'll see that the pods are being terminated again because we roll out to the previous version. There's already new set of pods running. Let's also look at the rollout history just to see how it looks like. So it's kubectl rollout history, name of the resource, kind, and then the name of the deployment, which is hello. So you'll see there's the number, the third revision, which is basically the same as the original one. So we went back to the original state when we undoed the rollout.